नमस्ते बच्चों, आई एम Jvn Dr Surendra Kumar from the Department of Science under the Faculty of Education and Methodology, Jyoti Vidyapeeth Women's University, Jaipur. Today we will learn about the linear span. First we understood the topic linear combination. By the previous lecture we have discussed linear combination. We recall here, suppose x1, x2, x3 and so on xn are the vectors which belongs in V. Then an expression which is associated with the scalars alpha 1, alpha 2 and so on alpha n, such that alpha 1 x1 plus alpha 2 x2 plus and so on alpha n xn. Then these expression is called the linear combination of vector space of vectors x1, x2, x3 and so on xn. Since by the property of vector space there is a property scalar multiplication, that is alpha is a scalar which belongs in field F and x is the vector which belongs in V. Then by scalar multiplication alpha x also belongs to V. So we can write this alpha 1 x1 belongs to V, alpha 2 x2 will also belongs to V, and alpha 3 and alpha 3 x3 belongs to V, and so on alpha n xn belongs to V. Then by closure property, or we can say by the property of vector space, alpha 1 x1 plus alpha 2 x2 plus and so on alpha n xn will also belongs to the V. This was the definition or recall or short introduction of the linear combination. Now come to the point, linear span. If S is a non-empty subset of a vector space V, then the set of all linear combinations of finite sets of elements of S is called the linear span of S and denoted by Ls. Since alpha 1 x1 plus alpha 2 x2 plus and so on alpha n xn belongs to V, it is evident that Ls is subset of V. That is, Ls is equal to alpha 1 x1 plus alpha 2 x2 plus alpha 3 x3 plus and so on alpha n xn, such that n belongs to n, x1, x2 belongs to S, and alpha 1, alpha 2 and so on alpha n belongs to F. Now a theorem. The linear span Ls of any subset S of a vector space V over a field is a subspace of V. For proof, let alpha, beta belongs to F and x, y belongs to Ls, such that x is equal to alpha 1 x1 plus alpha 2 x2 plus alpha 3 x3 plus and so on alpha n xn, and y is equal to beta 1 y1 plus beta 2 y2 plus and so on plus beta m ym, where alpha I, beta j belongs to capital F and xi, yj belongs to capital S. For I is equal to 1, 2, 3 and so on n, and j is also 1, 2, 3 and so on n. Then by alpha plus beta y is equal to alpha x1 alpha in bracket lambda alpha 1 x1 plus alpha 2 x2 plus alpha 3 x3 plus and so on alpha n xn plus beta 1 y1 plus beta 2 y2 plus beta 3 y3 plus and so on beta m ym. That is equal to alpha of alpha 1 x1 plus alpha in bracket alpha 2 x2 plus and so on alpha n xn plus beta in bracket beta 1 y1 plus beta 2 y2 plus and so on beta m ym. Thus alpha x plus beta y has alpha x plus beta y has been expressed as the linear combination of finite set x1, x2, x3 and so on xn, comma y1, y2 and so on ym of the elements of S. Consequently, alpha x plus beta y belongs to Ls. Therefore, alpha x plus beta y belongs to Ls for all alpha comma beta belongs to F and x comma y belongs to Ls. Hence, Ls is the subspace of V. It means linear span of S is the subspace of V. Thank you.